And in chapter 6, this is where trigonometry, which normally deals with triangles, connects to circles. Okay? So what we have here is something called the unit circle. If you'd like to highlight that in your notes, this is the unit circle. The unit circle is just a circle with its center right at 0, 0, and its radius of 1. You know equations of lines, you know equations of parabolas. We've done chapter 3, so now you know equations of square roots, equations of x cubed graphs. Here is the equation of a circle. X squared plus y squared equals 1. So that's new, but we're going to find out where does this equation come from and how are circles related to triangles. So we start by just picking a random point on the circle. If I pick a random point on the circle, since the circle has a radius of 1, that line will equal 1. The height of that line will be, since I picked some random point x comma y, the height of that line will be y, and the length of that line will be x. And I just drew a right angled triangle. First of all, going back to the equation. What formula can you do with right angled triangles? Think back to your trigonometry. This one you could probably even go back to grades 7 and 8. A squared plus b squared equals c squared, right? Well, what are my sides here? A squared, well that's x, plus b squared, well that's y, equals c squared, what's our hypotenuse? Well, it's a unit circle, so it's 1. 1 squared is 1. And because you can make a triangle anywhere on that circle, a squared plus b squared equals 1 everywhere. And so no matter which point you pick that does that, you plot all those points, you make a perfect circle. So it's kind of neat to see that the equation of a circle is just really a squared plus b squared equals c squared. If you wanted to make the circle bigger, you would change this 1. You know, if you change this to 2 squared, you'd have a radius of 2. If you changed it to 6 squared, you'd have a radius of 6. If you didn't want the circle center at 0, 0, you could do transformations left and right and up and down. But we're not going to worry about that. We're just going to start off with x squared plus y squared equals 1. Now, that connects a circle to a triangle in one way. In a second way that it connects a circle to a triangle is on this unit circle, we picked a random point x comma y. But the other thing that we know about trigonometry of right triangles is that sine is the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tan is the opposite over adjacent. So if we labeled an angle in here, there's our angle theta, we could say that sine of theta is the opposite over the hypotenuse. Well, what's the length of my opposite side? Y. What's my hypotenuse? 1. So I could write y over 1. Can you see that that just simplifies to just y? And if I did cos of theta is adjacent over hypotenuse, which just simplifies to x. And if we did tan of theta is opposite over adjacent, which is y over x. If you turn your page to 470, On page 470, you have a space at the bottom. And in that space, we're going to write 3 big ideas. Big idea number 1 relates to what we see right here. If I pick a random point on the circle, on the unit circle with a radius of 1, and I notice that sine of theta is equal to y and cos of theta is equal to x, I can now rewrite, you know, I picked a random point x comma y, I can now rewrite that point. Instead of x, I can say, well, x is just the same as cos of theta. And y, well, that's just the same as sine of theta. So now we can rewrite points on the unit circle. Instead of using their coordinates, we can just use the angle instead. That's big idea number 1. So we'll write that out. Points on the unit circle have the coordinates cos theta, comma, sine theta. Number 2. The equation of the unit circle, which is just Pythagoras, is x squared plus y squared equals 1. But if the points on the unit circle, big idea number 1, are cos theta, comma, sine theta, in other words, cos is replacing your x value and sine is replacing your y value, then instead of saying the equation of the unit circle is x squared plus y squared equals 1, this means x is cos, cos squared. Now, for sine and cos, when we square them, we write the little squared in between the cos and the angle. Cos squared, same thing for sine, plus sine squared is equal to 1. This is very powerful because we can do some crazy mental math now. Okay? If you typed in sine of 45 degrees into your calculator, okay, it would tell you a number. Take that number, don't type it into your calculator, just memorize it to say 5 decimal places. Okay? You good? Now, I want you to take that number with 5 decimal places and square it. That's really easy mental math to do. So you just took sine of 45 degrees, memorized 5 decimal places, and now you squared it. Keep that number off to the side, don't forget it. Now I'd like you to take cos of 45 degrees. Again, keep about 5 or 6 decimal places. Square it in your head. Keep 5 or 6 decimal places again. And now you have another number. Add those 2 numbers together. What do you get? 1. Good. See? Got some really good mental math happening. No, you didn't remember all the decimal places in between. But if the angle is the same, cos squared of 13 degrees plus sine squared of 13 degrees, it's equal to 1. Cos squared of 852 degrees plus sine squared of 852 degrees is equal to 1. As long as the angle is the same, this is a rule that's always true. In fact, it's the very first thing or first formula on your formula sheet. And big idea number 3, from our unit circle and SOHCAHTOA, we said tan of theta was the opposite over the adjacent. Okay? But if we think about big idea number 1, and y is equal to sine of theta and x is equal to cos of theta, then tan of theta is always sine of theta over cos of theta. We use big ideas 1, 2, and 3 so much this year that by the end of the year, you will just think tan of theta is sine of theta over cos of theta. That's common sense. Everybody should know that. You get that in math. Would you agree that everybody you see your age knows a squared plus b squared equals c squared? You would be surprised. You've never heard of that? If someone said, no, I've never heard of a squared plus b squared, you'd be like, really? Because you now think it's common sense, right? You didn't think it was common sense back in grade 1, right? Grade 1 come to you, hey, a squared plus b squared equals c squared. You'd be like, no idea what you're talking about, right? Grade 1, it's like, hey, 1 plus 1, 2. That's what you have is your common sense in grade 1, right? Now you have certain things that are common sense. By the end of this year, these 3 big ideas, they're going to be common sense. You're going to say tan theta, sine theta over cos theta. I know that. Sine squared plus cos squared, yeah, it's equal to 1. I know that right away. But right now, it's new. These are going to be the big ideas that form this unit. Some other things for this unit that are important. So here we've got sine, cos, and tan. We also learn reciprocal trig functions this year. We learn about secant. So secant of theta is 1 over cos. That's its definition. Cosecant of theta is 1 over sine. And you're going to get mad at whoever decided on these definitions that secant starts with an S, but cos starts with a C. And cosecant starts with a C, but sine starts with an S. If they would have just matched up the letters, it would be so much easier to remember. But now you have to remember they're opposite. Cotangent is easy to remember that it's 1 over tangent of theta because the words sound the same. Right? They should have named the other ones something you could remember easy. Like instead of secant, if it was like supercosine, you'd remember it goes with cosine really easy. And sine could be supersine. Then you remember easy. But no, you have to remember that cosecant, that goes with sine, and secant, that goes with cosine. You're going to have no problem remembering that cotangent goes with tangent. They seem to work that way. So these are other definitions that we're going to use in this unit. Those are our 3 big ideas.